All right, hello Honor Chem students. What we're going to talk about today is solubility, and you guys had just finished that solubility and temperature lab gizmo that was assigned yesterday. And so I want to explore a little bit about what solubility means. Well, as chemists and scientists, we consider this term like dissolves like, and what that means is that polar substances like water, we know water is a polar molecule, and alcohol has some polarity to it as well, so they will dissolve each other, and that's what we call like dissolves like. So a polar substance will dissolve another polar substance. Ionic compounds, although are not polar, they are extremely a positive charge and a crystal made out of a positive charge and a negative charge. So most ionic compounds, and notice I said most because there are some exceptions, are soluble in water. Non-polar substances, so things like your greases and your oils, they will dissolve other non-polar substances. So an oil will dissolve into a grease, but you know from your everyday experience, oil and water do not mix. And that is mainly because their polarities are different. So basically, dissolving occurs whenever a solute and a solvent have similar polarities. Now, of course, there's going to be some exceptions when you go on to college or if I see you in AP chemistry, but we'll deal with that then. So this is just kind of a general rule of thumb about solubility, that like dissolves like. Okay, so what that means as far as what does it mean to be dissolved, or what does it mean, here's another word, to be soluble, which means that it has the ability to be dissolved. Well, there are what we call solubility rules, and this is from your textbook. There's a table and it's on page 437 in your textbook, and there are just what we call general solubility rules. And really, the only two that you should really know are that anything that is in group 1, so if you notice like sodium, potassium, lithium, rubidium, and the ammonium ion, NH4+, they will always be soluble in water. And nitrates, and for the most part, acetates and chlorates, but for sure nitrates are always soluble in water. So that means that any compound that you have, it will end up being soluble in water. So let's say that you're thinking about a compound, I don't know, maybe you're thinking about something like sodium nitrate. So I'm going to write Na, I'm going to try to write Na. It is not cooperating very well today, so let's see if I can start over. So what if I were to write sodium nitrate? Oh, that's very bad today, but we're going to give it what it has there. So sodium nitrate, that's supposed to say NaNO3. Okay, would that be soluble in water? And the answer is yes. And it's really because all nitrates are soluble in water, and also all sodiums are soluble in water. So you might say, well, okay, then what if you have something like silver nitrate? Would that be soluble in water? Something like AgNO3? And the answer is yes, because it's got a nitrate. What does it mean to be soluble in water? It would look like this. It would be a solution that you could literally see through. These also you can see through, although the picture isn't all that great. They're colored, but they're clear. What a precipitate is a cloudiness that would happen when you add two compounds together. Similar to here, we're having two clear liquids that end up making a yellow compound. And if you remember when we were back in term 3, we did some precipitate reactions when we were practicing writing our ions. Okay, so a polar compound is one in which we'll have some polarity, like a partial charge. Like this is an ethanol molecule, and this part of the water of the ethanol is polar. This part is nonpolar, but it's polar enough that it will dissolve in water. And we know that water is a polar molecule. So if you would recall, this is your partial negative on this side, this is your partial positive on this side. So there's a plus sign there. And there will be an attraction between the water and the ethanol, and that's why they would dissolve. And I'd say, do you remember what kind of bond this is? This would be a hydrogen bond. All right, so as we're thinking about solubility then, we would want to understand what solubility really means. And solubility is the amount of solute that can dissolve into a given solvent at a given temperature. So hopefully you learned from the lab that temperature has some component, it has some relationship with the solubility. What you should have learned from that lab was generally when we were looking at solids, as the temperature increased, generally the solubility of the solution, that solid dissolving in water, that increased. Okay, and there is really a kinetic molecular theory for that, which we'll talk here at the end. How is it that it makes sense that as temperature is increasing, the solubility of that solute will also increase? Okay. This is a solubility curve, and there's lots of different compounds here, and you will never have to memorize this. If we ask you to do solubility problems, you're going to see a solubility curve like this. There's one solid here. Do you notice it's CeSO4? So I guess that would be cerium, I think it's cerium 3 sulfate. That does not follow that general trend that as you increase temperature, the solubility is increasing. You can see that because the slope of this line is decreasing. All right. Okay, so we're going to talk a bit about what it means to be saturated, and I'm going to look at this potassium dichromate line, which is this kind of, I guess it's kind of a blackish purplish line that I see right here. That's the potassium chromate. And so a saturated solution would be one in which the amount of solute, so this solubility curve is about the amount of solute. So notice how it says grams of salt, so that would be your solute, that can dissolve in 100 grams of water, or since the density of water is 1 gram per milliliter, we can say 100 milliliters. Okay, that's called the solubility. How many grams of this salt can dissolve in 100 grams of water? And notice it's temperature dependent. If we were to look here at the saturated solution of potassium dichromate, it looks like about 22 grams of potassium dichromate could dissolve in 100 grams of water at 40 degrees C. But if we go all the way up here to about 80 degrees C, it looks like a lot more can dissolve of potassium dichromate. Almost 58 grams of solute can dissolve into that 100 grams of water. So what we say a saturated solution is that it's really a point of the maximum amount of solute that can be held in the solvent at a given temperature. I know I don't have this written here, but you guys should write this down. A saturated solution is the maximum amount of solute that can be dissolved in a given amount of solvent at a given temperature. And what we know about it here is that it is clearly a point on the line. So a saturated solution is a point on the line. So if I were to look at 50 degrees, right here at this point, I could say I can put in 30 grams of potassium dichromate at 50 degrees of temperature. You can see the potassium chlorate here. This is dichromate. This is potassium chlorate. You can see the potassium chlorate, it can't put as much potassium chlorate in. You can only put in, it looks like about 28 grams. So a saturated solution is the maximum amount of solute that can dissolve in the solvent at a given temperature. Unsaturated means that it can hold more solute. So it can hold more solute at a given temperature. we call that an unsaturated solution. So if I'm looking at this potassium dichromate and I say that at 50 degrees I want to put 25 grams in, which is about there, that would be an unsaturated solution. Okay, then the last point that I want to talk about is what it means to be supersaturated. Okay, so supersaturated is a solution that can hold more solute than it normally could in its saturated form. We're going to watch a really brief video of a saturated solution to help you guys understand and what really a saturated solution is. This is from a scientist, a chemist, a chemistry teacher who made up a solution of sodium acetate. And if we were face to face and I was in my lab, I'd be able to do that and show you guys this video right here.
Okay. Just really quick, I'm going to add one tiny seed crystal. I'm not sure if you can see on the tip of that.
So he's adding just a little bit of
add that to my supersaturated solution of sodium acetate.
Of the solution of sodium acetate.
And we will see it go from a supersaturated state to a saturated state in just a few seconds. Isn't that cool? So we see that the sodium and acetate ions recognize the crystalline structure of that seed crystal I just added, and they add to it, and we form one big crystal. Now when I tilt this to the side, you can see it looks like a big chunk of ice, doesn't it? So now we're back. There's a little bit of water in there. You might be able to see it, but we're back to our saturated state right now. So we've gone from supersaturated to saturated in just a couple of seconds.
All right, so that's an example of a saturated or supersaturated solution. They're not very common. You have to do some unique things and they're kind of difficult to make. But these are also the things that are made up of hand warmers, the reusable kind. So those would be a supersaturated solution. All right, I think I'm going to leave it at that, and there's going to be another video to finish this lesson. So that will be where you'll want to go next.